Hey, good morning, everyone. I think this is too early morning, a lot of noise. Show of hands, how many of you are awake? Okay, everyone is awake. Hey, my name is Gaurav, and I work as principal engineer at Yahoo. And I've been associated with teams that develop core SDKs that are used in Yahoo, across Yahoo, in headquarters as well as other offices. Examples of common SDKs use deep linking, user experience, monetization, instrumentation, analytics, and so on. So today I am here to talk about a problem that we faced while working on the ads SDK, the monetization SDK. So the business problem was simple. We wanted a capability to run A/B tests with the ads. So in essence, what we wanted is a simple option, a fast option, where we could run some ads and do, on one extreme, a simple configuration or simple change of the UI like this, which is nothing but changing colors. On a little more complex side, we wanted to change a little more layout. So if you look at the learn more text, it has moved from right to left. And on a really, really extreme case, we wanted to go from a simple layout like this to a more complex layout, and all this without requiring, if possible, an update. And looking at the problems that we had at Yahoo, we have about a dozen apps. And if we release a newer version of our SDK for supporting these new templates, it would mean a new update to all the apps. And we cannot go to update the app just because we wanted a new flavor of the ads. I mean, nobody likes ads, but we get paid by ads. It's a different thing. Okay, so what I'll be talking about today, the agenda for today will be looking at the engineering problem, looking at what options are available in common today, the solution that we ended up investing into and why did we do. We'll run through a quick demo. Not every solution is perfect, so we'll look at what are the challenges that are there with the current solution and if we can solve those challenges. And in the end, we'll have some time for Q&A. So let's start with the problem, the engineering side of the problem. So what we wanted is to create and render dynamic UI, preferably controlled completely from the server and without deteriorating performance. So examples of dynamic UI is that you can change the color, the background color, the font size, and other things. Those are like basic configurations to change. We may want to change a little bit on the spacing, so you can change a little flow of the ad itself. Maybe change the relative positions of the visual elements. You want to move the elements from left to right or from top to bottom, or maybe change the elements altogether. You want to move from button to maybe a more styled text view. Gives a similar visual appeal, but completely different elements. You may want to do it just for the sake of performance itself. So the challenge that we had was, on one dimension, we wanted things which are completely dynamic in nature. Performance is not really orthogonal, but probably takes your app into a different direction. So if you want performance, you have to sacrifice dynamicism, or you cannot have both the things running simultaneously. It's very difficult to do it. And more importantly, whatever we wanted to do the things very securely. So when we send the data from the server to the client, it should not be possible for anybody to intercept the layouts that we are sending from the server and be able to change it. And I mean, simple things is, instead of showing maybe an image, if somebody interjects the data, he may end up in showing a login prompt and can probably grab the user's credentials. So what do we have common options that exist today? We can use runtime configs. I'll just talk brief about that. So very, very commonly used technique. HTML5 use WebViews. Nobody likes WebViews, but they are perfect for some of the solutions. Or if we want, we can create our own custom domain-specific language. Instead of working with raw XMLs, if we want, we can create our own language and gain complete control over the things that we want. So runtime configs, as I said, most commonly used options. So probably your server will send your protobuf data or your JSON data. On the client, you understand the keys, process the data, and update the UI. So the challenge that we have with the runtime configs is they are constrained by these hooks which are defined at the compile time. So if you have a configuration which says this key is used to control the text size, you can only control the text size. You cannot control the background color, for example. So you cannot add new configurations, new hooks, new properties on the fly. Whatever goes compiled in the app, those are the only entries which are understood and processed on the client side, which means that you can use runtime configs, but if you want a true dynamicism, you still probably may have to update your app and release a new version. So examples will include your typical A/B testing frameworks. You can create your baselines, you create your variants, code the variants, code when you are into a bucket, code, you show something else if you're in a different bucket. Then we have HTML5. Now it is a great choice because it helps us to do fast prototyping and render almost anything. And the good part is we can use WebViews, we can use HTML5 to render dynamic UI without much efforts. However, there are performance issues with the WebView, and everybody knows that. For some applications, WebViews may be just perfect. We use WebViews to read mails. We use WebViews for quite a few other things, but we did not want ads to be the slowest part of the system. If ads slow down your system, if ads slow down your app, probably you should remove the ads. So we could not use the WebViews in our case. Especially when you have to use multiple WebViews, for example, in a list view, things can really get challenging in terms of performance, in terms of getting high rendering rates. If you want your application to be at 60 FPS, it's very difficult if you have 5 WebViews in a list view running together. And there are reasons why native applications are native. So native elements are more accessible than WebViews. Native elements perform better than WebViews. Some of the common frameworks that use HTML5, Apache Cordova, or the PhoneGap common name, is one of the most common frameworks. Then you have Sencha, and you have other frameworks that you can use to use HTML5. And then we have the domain-specific language. You can create your own custom language. The great part about DSL is it gives you maximum control. You can do whatever you want because it's your language. You're writing your code for parsing that. However, there are overheads of working with DSL. You have to define a DSL, ensure that it is able to cater to as many requirements as possible, and then you have to evolve DSL. You have to maintain the implementation. And your custom DSL, the parser, the runtime, means that you have a huge amount of code that you have to manage, ensure that it is bug-free over time. When you have a DSL, probably you have another DSL runtime running on top of either Dalvik or ART. Now, if your DSL runtime is in Java, you have another Java engine running atop Dalvik, which can be very slow. If you have a DSL running in native, there are issues which you cross over from JNI to Dalvik and back. So if you look at the view system of Android, it's completely written in Dalvik, it's completely written in Java. So if you make your UI from your native C, C++ code, and then try to render the UI, it's not only the JNI border that you have to cross, there are overheads of working with the UI engine. So some of the common examples, or in fact 2 examples that are very popular or evolving these days with domain-specific languages. One is React Native from Facebook, and then you have Anko on Kotlin. So Anko is, in fact, a very sweet language, sweet DSL if you want to try it out. However, there are challenges, again, with DSL in terms of performance. You can do some fancy stuff using the concept of method swizzling on iOS, which gives you a lot of things transparently. However, those advanced techniques are not available on Android. So DSL, again, there are some constraints that we live with. So what's the alternate solution that we did? So we'll take a step back. Let's look at the specs once again. We wanted to have a flexibility like HTML5. We did not want to introduce the overheads of a DSL. And we wanted to be close to the performance as of using simple configs. Now, the 3 things together are quite challenging to go through. So what's the observation that we had? One is native layouts are compiled and baked into the APK. The language for writing the layouts exists, and that's the XML language itself. It's just that using the default layout loader, LayoutInflater, there are constraints of using it out of the box. And the constraint is that layout has to be bundled with the APK. The question was, can the layouts be loaded from an external source? Can we download the XML, whether it is raw XML or compiled XML, down from the network, down on the wire, and load it dynamically on the device? So what we needed was probably a product manager that designs the template, pushes it to the internal repository. We push that template down to the CDN. The product manager creates some experiment, says, hey, you are into this bucket, you probably are going to use this template, publish the experiment, and as far as the user is concerned, it gets the data related to the experiment and says, hey, I need to now use this template, go to the CDN, download the template, and proceed. However, challenges that we had. The LayoutInflater does not accept raw XML layout. So the inflate method does have a parameter called XML pool parser, but that doesn't work with plain text XMLs. So the method inflate fails, and it fails actually on a JNI call. LayoutInflater will not accept compiled XML from an external source, so it will not accept raw bytes of array of bytes, or input stream or whatsoever. So we cannot create an XML pool parser just from raw input stream. And there is no layout ID associated with it because this layout exists on the server, does not exist in the APK. So r.layout.blah doesn't exist. So we got an idea. And the idea was, well, read Android source code because it's loading the XML layouts. If Android engine can do it, OS can do it, why cannot we? So Android OS does inflate the compiled layouts. So this is the code that we stumbled upon. We're looking at the code. So if you look at the view inflate, gets the layout from the resources, gets some parser, inflates using the parser. The parser uses something called XML block. So all we need is just get hold of this XML block and work with it. So all we needed is the access to this class called XML block, which belongs to this package, Android content res. The great part about this class is it's hidden. Unless you compile your own android.jar, you will never be able to access it. But there is an alternative, and that alternative is probably use reflection. Reflection always raises eyebrows. Reflections are slow, but this was more like a deliberate call that we take. We'll measure the performance of doing a reflection on this class. The good part is this XML block class is very lightweight. It doesn't have hundreds of methods. It probably has 10 or 12 methods. So using the reflection on this XML block class, getting the instance and then working on with the methods is what we actually ended up in doing. So what we have a code is something like this. You get hold of the class XML block. Constructor takes the raw bytes. These bytes have to be of the compiled XML, not the raw XML, not the plain text XMLs, which means you will have to pre-process the XML layout that you create. Get hold of the method new parser, invoke, and you are done. As simple as that, which means that probably if you use this solution, the method count of your app increases by 2 or 3. It depends upon how you refactor, how you factor your code. So it doesn't impact your 64K limit as well. So what we have is now this new step in the process, which is compile the template, because that is what is understood by the inflator. So I'll quickly run through a demo, which demonstrates the capabilities of the code that I have. The layout that you see right now is a native layout. So I have done set content view r.layout.blah inflater.inflate. The one that you see here is actually coming from a network. This compiled XML has been downloaded from the network. Same on this one. It's downloading the image, I guess. What more you can do is you can change these on the fly. So this is r.layout.blah. This is coming from the network using custom code, XML block. And this is yet another layout, which is again coming from the network using XML block and running the code from it. Okay, this image is heavy, I guess. Okay, not every solution is without challenges. If it were, probably everybody would have been using it. So let's start with challenge number 1. Because the layout is compiled independent of the original applications, which means that all your resource IDs are invalid. You cannot use any references at string / blah, at color / blah, at drawable / blah. They are not usable because they are compiled by AAPT in a different context for the new template. And the IDs which are mapped into your application, they are very different. And we know every time we create a build, every time we run AAPT, the IDs that we get probably are very different. Side effect, find view by ID doesn't work because at ID / blah doesn't work at all. There are security risks. Anybody can hijack the compiled layout, can inject your code into it. We'll see how do we mitigate that risk. And there is yet another challenge right now, which is we cannot use themes. So style equals blah, that doesn't work. We have some solutions or answers to some of the questions. One is don't use at color / blah, hard code the colors, hash, ABCD. There is again some constraints, which is if you want to use a drawable, you cannot use it. You'll have to code it in your app. It cannot be bundled in the compiled XML. If you cannot use find view by ID, you can use at least find view with tag. So each of the elements, instead of saying at ID equals, Android:ID equals, you'll say Android:tag equals XYZ. You can mitigate the security risk to some extent, or in fact to a large extent. You sign the templates. So now when you send the data about the templates, not only you send the raw byte, but you also send the signature. And the private key is agreed upon, the public key is baked into the APK, so you always validate against that key, you pin against that key. Themes is something that I'm still working upon. As of now, I think I have a vague solution, but I still haven't given a complete blow to it. So this is a hard constraint. We cannot use themes. You cannot say !, style equals blah and work with it. So if you have a lot of themes to be used, probably you may not want to use this solution right now. Cool. So what we had a previous step was a solution like this. Now we've got a new step, which is just sign the template. Cool. So in a summary, what we had was the LayoutInflater loader can be used to load the layouts of APK from any other source. There are some constraints of using this technique. There are some constraints which are solvable. There are some constraints which are unsolvable, at least as of now. Having said that, I think it's a good option if you want to run quick A/B tests. You don't want to release a new version of your APK every time, especially if your app runs into 10s or 20s or 50s of MB. Just for 200 KB of layout, you don't want to have the user download another 10 MB of your app. So anybody who is interested in the code, this way you can download the code. It's there on GitHub. Yeah, there goes the cameras. and those are some related references to the pieces of code directly hooking onto the API that you will be interested in looking at. Okay, I'll give you enough time to take the photos of this one. That's it from me. The floor is open for questions.
So if you want to, for example, download the image to, let's say I'm using Glide, I want to download the image and set it based on some like an image view that I got. So I find it based on the tag and then use Volley, for example, to download the image and set it.
Yeah, so the question is, if I have an image view, how can I set the image for the image view? Let me run you through a very quick code itself. Just 1 second, it should. So if you look at the code goes something like this. So find view by ID doesn't work. Your layout, whatever you have got it from the custom layout loader, so I'm connecting to this local server here, downloading the layout, loading it and everything. And then once it has been created, I'll say find view with tag and then work with it. So yeah, so use Glide, I use Picasso here. This is the same thing. Cool, yeah.
Have you talked about this?
Yeah, go ahead. I think you just have to be closer to the mic, I guess.
Have you talked about this issue with Google engineers?
What issue? About the theme?
Yeah, so if you have talked about the issue of being able to dynamically load layouts with Google Engineer, maybe they could provide a solution that would work without reflection, or?
Yes, I still haven't talked to them, but it's a good idea. I should approach them. I am actually, I'm supposed to approach them for yet another piece of project that I'm working on, which is how do you load the layouts faster, because the custom LayoutInflater uses a lot of reflection, and we have seen even loading a simple layout at times can take up to 30 to 40 milliseconds. And if you are on a list view scrolling very fast, 40 milliseconds, will get bump as you load it. So yeah, it's a good idea. Talk to them. Probably say don't hide XML block, but until API level 23, you still have to live with it. But it's a good point. Yeah.
So it seems like you have a different solution between Android and iOS. Do you feel like it's worth it to kind of like because in Android you're loading the XML runtime, and obviously in iOS you're not loading.
So if your question is iOS and Android have different solutions, by the way, this solution can be applied, and we have used it for iOS as well. So
the question is, do you think it's worth it to actually consider a single solution that works for both, or just something?
okay, having a single solution that works for both depends on what is the implementation. Conceptually, the implementation can be same. So conceptually, it can be DSL. Conceptually, it can be compiled layouts served from the server. Implementation, of course, have to be native. So if that answers your question.
And I guess another one, how do you handle like interactions? Like let's say you have a button, and let's say you want to link that button to another thing.
Good, great question. So question is, how do you handle the interactions if you want to serve layouts with different animations or different interactions? No, you cannot. The reason is, as far as the guidelines for publishing your app on Play Store is concerned, it says that you cannot download dynamic code, like you compile class files or jar files from external source and use it in your applications. The only thing that you're allowed to do is JavaScript, and that too within a WebView. So even if you look at approaches like React Native, the interactions and the options, what is possible, all the possibilities are there with the application, with the APK, with the runtime. Only thing that you change from the server is what you want to do. What are the options that you want to pick up? That's only which is served from the server. Yeah. Yes?
How does it scale in production?
Okay, how does it scale in production?
How's performance in production, and which apps are doing this right now that we can take a look at?
Good. So right now, all Yahoo apps use this for A/B testing their ads on the device. And we use similar option for both Android and iOS. iOS also, we compile the templates and send it down the wire. So if that answers your question. Every app has it. Every Yahoo app at least has it. Any other questions? Okay, this one.
So the resource R class is compiled into the R class, which are just essentially numeric references to items in the package. So it feels like, at least in theory, you should be able to link against a particular version of the R class and then use that for the deployment. So it seems like something you could possibly do.
Theoretically, yes, it is possible. So the question is, the R IDs do exist, and can we use them? So instead of going through a find view with tag or unable to use the references. Can we use it? Theoretically, yes. The r.txt has all the mappings. If you look at, it contains all the IDs and the numeric values. The only challenge with that is doing it at scale. What happens is for every build, there's a possibility that the new IDs may be generated. So the APKs of the same app, if they are compiled on two different boxes or even on the same box, the different times that they are compiled exactly the same code may yield different IDs. So which means that for every version, you have to now keep a track saying that if the user belongs to this version, okay, probably give this layout. So for the same app, if you have 10 different versions which are live, you'll have to maintain 10 different versions of the layout on the server side. So scaling can be a little tricky on that part. But theoretically, yes, it's definitely possible. Cool. So if there are no other questions, okay, one last question, okay.
What's the process for compiling the XML on the server?
So there are two ways that you can use. One is you can write a command line utility that just runs APT on it, or like in the case that I have on the GitHub, for the sake of completeness, I have like two different projects which works here in this case because they are simple layouts. But definitely what you can always do is, okay, I cannot see the projects. So in the real world, what you will have is, let's say this is my app. You probably have your, code for loading the coding the layouts dynamically bundled with the app itself. And later on, you, the product manager, the engineer, designer probably will sit together, work in the same app, create a new layout completely, see that it works in the app, gives good experience, and then all you need is compile, extract the XML from the APK itself, and you can automate that very easily. Cool, thank you. That's it from me.